All right, basic algebra D. I'm going to continue working through solving or graphing rather, graphing from vertex form using transformations. And there were two ways that we've been working on doing this. The first way is transforming the parent graph. That's taking the points, the parent points from our graph and moving those points. The other way is by transforming the parent table. So here's kind of what I've decided I'm going to work on. If we have any sort of vertical stretch, so that's our numbers out front multiplying, and I'll show a few examples. So vertical stretch of 2, right? We have this only has a flip. This only has a flip. This has a flip and a stretch. So anytime that we have a stretch, I am going to use a table. Anytime that I do not have a stretch, if I only have a flip or nothing at all, right? If I only have a flip or there's no changes, then I will move my parent points. But if I have a stretch, it seems to work out best to use a table with a stretch and moving the points with a flip. So I'm going to just pick two of these. I'm going to do number 11 and I'm going to show you number 13. My goal is to kind of work through all of these, but just do just like two at a time for these videos. So for number 11, I have a stretch of 4. So I'm still going to list what's happening just because good practice here to see. So I'm going to have step 1 in purple. I'll list step 2 in red. And then step 3 in blue. So step 1, we do the opposite. So the opposite of plus 2 is to move left 2. And then we are talking about our second transformation is a stretch of 4, a vertical stretch of 4. And then our third thing is we're moving up 1. So because we have a stretch, I am going to use my table. And you'll see the table is just easier to work out what happens with a stretch. If we don't have a stretch, it's pretty easy to just move the points. I think that's been the most confusing part. So I'm using my 5 favorite numbers here for our parent table, which is if there were no transformations taking place and we just had y equals x squared. So this is like our most basic function of a quadratic. On a table, we use our 5 favorite x values, and these are the y values that occur. If we square -2, we get 4. If we square -1, we get 1. If we square 0, we get 0. 1 squared is 1. 2 squared is 4. So that's our table. And then the first step, the first transformation is occurring to our x value. Everything else is happening to our y value. So my x is going to be -2. It's moving left 2. So I'm going to say x -2. My y value is being stretched by 4, so it's going to be 4 times y, and it's moving up 1. So I'm going to have 4y plus 1. And then I'm taking my values and changing them by what was written down here. So I have -2, -1, 0, 1, and 2. And we are subtracting 2 to each of those. Okay. My y value, I have 4 1, 0, 1, and 4. Those are my y values, and those are all going to be multiplied by 4, and then we're adding 1. So setting up my table with my transformations and what's happening to my numbers from my table. So I'm going to use purple here. Negative 2 minus 2 is negative 4. We have negative 3, negative 2, negative 1, and 0. And then on my other side, I'm doing 4 times 4, which is 16, plus 1, which is 17. 4 times 1 is 4, plus 1 is 5. 4 times 0 plus 1 is 1. 4 times 1 is 4, plus 1 is 5. And 4 times 4 is 16, plus 1 is 17. A stretch of 4, think about it, because we wrote this down. A stretch of 4 means that my parabola is going to be way stretched out. And if you see here on the table, it's actually counting by 2's. So we'll kind of see how that affects it. But so I have my points of negative 4 comma 17, negative 3 comma 5. These should be in parentheses because they are points. I have negative 2 1. I have negative 1 5, and I have 0 17. So here's what I'm going to do. I'm going to plot each of those points on the graph. Negative 4, 17 is going to be halfway between 16 and 18. So it's going to be right here. I'm going to have to be using halfway points because this is counting by 2's. Negative 3, 5 is going to be kind of floating here. Negative 3 would be right in between here. And then 5 is going to be in between here. So I'm going to be right in the middle right there. Negative 2, 1. Again, it's like in between. Negative 1, 5 is going to be up here. And 0, 17 is going to be up here. So if you see a stretch of 4, look at how stretched out that parabola looks. It made it really tall and skinny. Okay? And then we'll talk about number 13. So number 13, for this one, I'm still going to list my transformations, and I will color coordinate those. So my first thing I'll talk about we'll do in blue, and then I'll look out front at this flip. That's going to be in red. And then we'll do purple for my +4. So the first transformation, we do the opposite of whatever's on the inside. So this is right 4. My second transformation is a flip. It's an x-axis reflection. We call it a flip. We're going to flip across our x-axis. And then we're moving up 4. And as I'm looking at this, I'm seeing, so this is part of that critical thinking kind of thing. Because I did talk about how I wanted to move the points, but now that I'm looking at my graph, I'm seeing my parent function. I don't have the right graph to put my parent function, right? Because if I have my 5 favorite points, 0, 0, 1, 1, 2, 4, and then my other points are somewhere on this side, but I don't really have any graph for doing that. So it's not very practical for moving those points. I will move points in future videos, but I'm going to do it based on kind of what the graph is doing and what information we have. So this one's not very practical for moving points. So because of that, I'm going to go ahead and just do a table. I use my 5 favorite numbers for my parent table, negative 2, negative 1, 0, 1, and 2. You should notice that these are always the same. 1 times 1 is 1. So there's my parent table. And then our first step affects our x, so that's going to be right 4. So we're saying x plus 4. everything after that is affecting our y. So we're going to have a negative y, because it's flipping, plus 4, because it's moving up 4. And again, it's almost like we take this whole x minus 4 squared thing, and we just replace it with a y. Still a negative out front, there's still a 4 there. Okay, so my x values come from my parent table, -2, -1, 0, 1, and 2. My y values come from my parent table for y, so I have 4, 1, 0, 1, and 4. And then I'm applying my transformation. In this case, I'm adding 4 to each of these. In this one, I'm taking the opposite. That's what a negative means. The opposite. And then I'm adding 4. And then we do we calculate it, we do the math. So -2 plus 4, signs are different, subtract, keep the sign a larger number. Same thing here, 4 minus 1, 3. 4 plus 0 is 4. 4 plus 1 is 5. 2 plus 4, 6. And then over on this other side, I'm going to do the opposite of 4. So the opposite of 4 is -4, plus 4 is 0. The opposite of 1 is -1, plus 4 is 3. The opposite of 0 is 0 still, plus 4 is 4. The opposite of positive 1 is -1, plus 4 is 3. And -4 plus 4 is 0. So I'm just calculating those out. I'll go ahead and list these points just that you see. 2, 0, that was from here. These correspond, my x and my y. And then 3, 3. And 4, 4. And 5, 3. And I'll squeeze this one in, 6, 0. Okay, and then we're saying 2, 0 would be right here. 3, 3 would be up here. 4, 4. 5, 3. 6, 0. And there's my parabola. And it should make sense that it's flipped, that it's facing down, because it's negative. So that's a good way to check to see if I did it right. Let's see. Can't really tell how long I've been recording. So we're going to go ahead and call that good. You get to see a couple examples. I'm going to keep ripping through examples over the next several days. And we'll just keep this fresh. The whole idea is just that you're seeing it and getting to kind of experience what's taking place with each one of these.